Can you guys hear me? Just out of curiosity, you can just respond in the chat. Yes, you can hear me. Okay, thank you. We'll get started in a little bit. We're gonna wait for a few more people to show up. We only have 6 people here right now. But what we'll do is we're gonna work out of the practice test, the SAT test that you guys took on Saturday. Okay, so on page 34, it starts at question like number 5. We're gonna work out of there. We'll get started in about a minute because we're still waiting on a few more people. However, if you are on, you can go ahead and get your practice test booklet out, the one you took on Saturday, about a week and a half ago, and open up to page 34, the math section. Okay, I'm going to go ahead and get started. So my plan for this session that we're going to have is I am going to go through a few problems that I have looked at your guys' results and seen that, you know what, we are really struggling with. And if you all of a sudden come across a problem that I skipped over, so for example, I have a few problems like circled. If I skip over your problem and you want to go over it, please just ask and I will happily address it with the entire class, okay? But there are these problems that just overall we struggle with. So one problem that a lot of students got wrong just by the results was number 7, okay? That problem is x over a squared over x to the power of a squared over x to the power of b squared is equal to x to the power of 16. You know that a plus b is equal to 2. And then your goal is to figure out what the value of a minus b. Now, just by, how long you've been in mathematics, some of you can see the light at the end of the tunnel for this problem. Some of you cannot. So one thing you definitely want to know is how to simplify. In order to simplify this, you have to remember your properties of exponents. The property there is if you are dividing two x's, you have to subtract the exponents. So if I do that, I get x to the power of a squared minus b squared, and that's equal to x to the power of 16. Okay, you can quickly eliminate the x's. Then you're left with a squared minus b squared equals 16. Now you just have to remember, how do you deal with a squared minus b squared equals 16? This is a problem where you only have one equation and 2 variables. And that's okay because I don't really care about solving for A and B separately. I'm told that A plus B equals 2. If I want to find A minus B, I just have to factor. So if you want to remember how to factor A squared minus B squared, it's A minus B, A plus B equals 16. And if A plus B is equal to 2, then something times 2 equals 16. Obviously, that 2 has got to be equal to, A minus B has to equal 8. Okay. If you guys have questions as I'm going through a problem, go ahead and use the chat feature. That'll be probably the easiest thing to use to ask your question. As I look through this problem, there is some things that I want to talk about, and that's just general rules. Let's say you see this and you're like, I don't remember the rules of exponents. Now, ideally, you all remember them. If you don't remember the rules of exponents, one thing you can always do is just make up numbers to see if that helps stimulate what the value or what the properties you're supposed to use are. For example, x to the power of 8 over x to the power of 5. Okay, I made up random numbers. I simplified it. I dumbed it down for myself because I'm like, wait a minute, if I have x to the power of something over x to the power of something, am I supposed to subtract? Am I supposed to add? What's the rule here? Well, the idea is subtract the exponents, right? X to the power of 8 minus 5, and we can simplify that to 3. You can't simplify all variables, but you can definitely simplify all numbers. So if you get stuck on something and you want to remember the rules, dumb it down for yourself, make it easy, see if that helps, and if it does, use that, okay? Any questions? Again, just type it in the chat. Another question that a lot of us got wrong, and this one I'm not really too surprised by. It is a tough question because you have to remember one specific property. And that's number 11, okay? Number 11 says, which of the following complex numbers is equivalent to that? So this comes down to the idea of rationalizing. Rationalizing is usually not a big thing unless it's with the value of I. So one thing you can look at is, well, they have all different denominators, and none of the denominators have an I in it. And that's the idea, is how do I get rid of this I in the bottom? That's the hardest thing to remember. In order to get rid of the I in the denominator, there's only one thing that you can do, okay? And that thing is multiply by what we call the conjugate. You have to multiply by 8 minus 2i. If I ever have a square root on the denominator, the only way I can get rid of it is multiply by square root. That means even if I had 3 minus 5 root 2 over 7 minus 5, or let's pick a different number, 4 root 3, it's not going to work to just multiply by itself, and it's not going to multiply by root 3. You have to multiply by 7 plus 4 root 3, 7 plus 4 root 3. Okay, I would keep that in mind only when it comes to like imaginary numbers or radicals in that case. So if I do the entire distribution here, 3 times 8, 24. 3 times negative 2i, negative 6i. Negative 5i times 8 is negative 40i. And negative 5i times negative 2i is going to equal positive 10i squared. Okay. We'll simplify that in a little bit, but let's figure out the denominator. 8 times 8, 64. 8 times negative 2i, negative, that's 16i. 2i times 18 is 16i. And 2i times negative 2i is negative 4i squared. If you remember, this is the big one, I squared is equal to negative 1. You need to recall that for imaginary numbers. I squared is always equal to negative 1. So the other thing I want you guys to catch is on the denominator, something very special happens. These two cancel. And then this I goes away. And that means all of the i's went away in the denominator. That's why I have to remember multiplying by the conjugate. So in the numerator, I'm left with 24 minus 46i, and then this becomes minus 10 all over 64, what is that, plus 4. So finally, I'm left with 14 minus 46i all over 68. And in that case, how does that reduce? Okay, well, because that's not one of the answers, but you can see some of the answers look very, very close to that. You can definitely eliminate some answers, You can eliminate B because that one has a plus sign. You can eliminate D because that has a plus sign. You can eliminate A because it just looks too easy. So really the answer has to be C, even if you don't know how to simplify. But what you really want to do is take all three of these values and reduce it by the same amount, which is 2. And you're left with 7 minus 23i over 34. And that's where C came from. Okay. All right. I'm going to do number 12, and then I'm going to see if there's any questions on this page. So you have R is equal to F over N plus F. This isn't too bad of a problem. You just have to remember that one other thing, and that's factoring. Now, the very nice thing about this is if I'm looking at this problem, I'm going to quickly glance at the answers. Something always advised, glance at your answers. You see that all we did in each one of those answers is solve for F. If you read the paragraph and you have no idea what the paragraph says, that's okay, as long as you know all I want to do is solve for F. Okay? So how do I solve for F? Well, you got to get rid of fractions. We hate fractions. Cross multiply. If I cross multiply this and then this and this, I end up getting R times N plus F equals F. You got to distribute Rn plus Rf equals F. Move everything to one side. Subtract Rf, subtract Rf. Rn, because you have to get F by itself, and the only way you're going to get that is moving all the F's to the next side. And then this is where everybody's favorite thing is. The only way you get down from having 2 F's to 1 F is factor out that F. I've seen way too many people make the same mistake though. If I factor out an F, don't forget, if I divide by F, that's 1 minus R, and then you divide that over. F is equal to Rn over 1 minus R. Okay, gotta remember how to factor those. Okay, are there any other questions you guys want to go over from questions number 5 through 12, or maybe even before number 12, 1 through 12? Take a look. I went over the ones that I saw the most common misses on, but if you have one that you were like, I don't understand how to do this one, just let me know in the chat, please. Sure thing. Okay, got a lot of people that are saying 8. So number 8, the measure A in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by a formula above. Okay, so NA equals 360. Again, what does n represent? Number of sides. A represents the angle, and it's the angle of an exterior angle. Exterior angle. Something that might help is just label stuff like this. If the measure of an exterior angle of a regular polygon is greater than 50, so A is somehow bigger than 50, what is the greatest number of sides it can have? Okay, so if A is something that's greater than 50, then what is the greatest number of sides? So we're looking at pretty much the maximum of n. So what I would probably start off by trying is maybe let's just see what happens if we plug in 50. N times 50 equals 360. If I divide by 50, now you have to do this without a calculator. Maybe you guys remember one of my tricks. If you divide by 50, then you are going to have n is equal to, well, you can cancel out the zeros. You have 36 divided by 5. If you have to figure out 36 divided by 5, it's not that bad. It's 36 is an even number. It's pretty relatable. But instead, here's my trick. Multiply by 2 and then move the decimal place over 1. So if I multiply by 2 and move the decimal place, I have n is equal to 7.2. Okay. Now you have to remember, A is bigger than 50, right? So if A is bigger than 50, then what happens if, A is greater? What's going to happen to n? n is going to get smaller, right? So if a gets bigger, n gets smaller. So if it says the measure of an exterior angle is greater than 50, what is the greatest number of sides it can have? The answer should be C. See if that is correct. Oh, Mr. Salter did not give me an answer key. Let me pull up the answer key that I have, and I can find it. Let's see, this is question number 8. Sorry about this. Just want to double check. Question number 8. Correct answer is C. Yeah. Okay. So that's the big thing with the inequalities is you do have to remember that since A is bigger than 50, N actually has to be smaller than 7.2. And one thing you can do just to kind of see what happens is plug in a number bigger than 50, okay? So if I plug in 60 hypothetically, N times 60 is equal to 360, N is equal to 6, right? So that means as A is getting bigger, as I escalate A, N is getting smaller, right? Okay, so it's got to be N is less than 7.2. And that makes sense because if you're multiplying two things, as one thing has to go up, the other thing has to go down in order for it to continue always equaling 360. Hopefully that made sense. Let me know if it didn't, or let me know if you have other questions on these 2 pages. Okay. Next question I want to look at is number 13. 13, there's about 3 ways to do this problem. And I'm going to try to show you guys all 3 because one of them is the longest way, which is the correct process that they want you to do. And then there's another way which all the people that are, strong in math, which includes you guys, should be able to do really quickly. So what is the sum of all values of m that satisfy 2m squared minus 16m plus 8 equals 0? Okay, so one thing I'm going to start off by saying is you are solving a quadratic. That's what you're trying to do because it's saying find all the values of m. So I don't know what m equals. And another thing that some of you guys already know, but I'm going to say it anyway, you don't know how many m's there are. Since you know you are solving a quadratic, you know you have a total of 2 m's, correct? All right, so we can definitely try to do a few things to try to solve this quadratic. Maybe you can do some factoring. Take out a 2. M squared minus 8m plus 4 equals 0. And then you figure out really quickly, this is not going to be as nice because, well, it doesn't factor, okay? So since it doesn't factor, you have to use quadratic formula. Before we start, complaining too much, quadratic formula is actually going to work out much better than you expect it to, because I'm going to get 2 values for m, right? And then I want to take that first m value and that second m value and add them together. Okay, keep that in mind. So when I do the quadratic formula, first of all, let's write what the quadratic formula is. Opposite of b plus or minus square root b squared minus 4ac all over 2a. I am not going to pick the original equation. I'm actually going to pick the second one. So I have a 1m squared, a negative 8m, and a positive 4, and plug those in for the corresponding values of a, of b, and of c. That's a c. Okay. So if I plug those in, I end up getting opposite of negative 8, right? This is opposite of b, so opposite of negative 8 is 8, plus or minus square root b squared, so that's 64 minus 4 times 4 all over 2 times a, so that's just 2, okay? And you can simplify this, 8 plus or minus square root, 64 minus 16, I believe is 48 all over 2. Don't think about trying to simplify this all the way. I know instinctively you guys want to. Think about this. You're trying to add the solutions, right? I have 8 plus root 48 all over 2. Plus, 8 minus root 48 all over 2. Correct? Well, what's going to happen if I add these together? The square root of 48 here and the square root of 48 here are going to cancel. They have common denominators. I can just add it straight across. They're going to cancel. So what am I left with? 8 plus 8, which is 16, all over 2, which is equal to 8. So the correct answer is 8. I was able to do that without fully completing the quadratic formula and not fully completing M1 and M2. I don't care about the individual solutions. If there's a problem that says, I don't care about the individual solutions, find out what they sum to, there is a shortcut you want to definitely take. Okay? Are there any questions with my work on the quadratic formula and how I eventually got to 8 before I show you guys an alternative technique? Okay, so I often see this type of problem where it says, find what the solutions add up to. Here's just a nice little piece of advice. If it shows up, you can definitely use it. Just gonna get rid of it highlighted. The trick is this. If I ever have a quadratic, and this works specifically for quadratics, okay? What you want to do is you want to take the opposite of the b value, okay, and then divide it by the a value. And that's it. That's what your two values are going to add up to every single time, okay? So if I look at the first one, the opposite of 16 is, opposite of negative 16 is 16. Divided by 2 is equal to 8. The opposite in the second one of negative 8 over 1, because the 2 doesn't have any m's on it anymore. So then opposite of that is just, again, positive 8 over 1, which is equal to 8. Okay? The reason this works, I'm going to give you guys a very, very short proof. Opposite of b plus or minus the square root of stuff. Well, no, I'll actually write it out because you can see. I'm basically taking the positive one and the negative one, and I am adding them together. And what happens? These cancel, these cancel. What am I left with? Negative 2b over 2a. 2's cancel. You're left with opposite of b over a every single time. Okay? That's a nice little hack, and it specifically works for quadratics. Now, before you say, well, if it's cubic, it doesn't work. I've seen this problem on the SAT. It says, here's x cubed minus 8x squared minus 15. Does that factor? That does not factor. Okay? 15x equals 0. Can you take out an x? Sure, I can take out an x. And then I have a quadratic that does not factor. Right? 3 and 5 don't work on this one. But regardless, I know I have one solution, x equals 0. And I know that the two solutions from here are going to add up to opposite of b over a is 8. 8 plus 0 is equal to 8. There's still what this solutions add up to. It's just a way of going around it and not having to do all the work. Any questions on number 13? Okay, I want to quickly talk about number 14. I'm not going to spend too much time on it because I think you guys did overall well. We had a better percentage, but there was one common thing that happened. So a radioactive substance decays at an annual rate of 13%. Keep that in mind. It's going down by 13%. Keyword there is the percentage. If the initial amount of the substance was 325, so initially is 325 grams, then which of the following functions models the remaining amount? Well, if you're not sure, you know initially you have this much, right? Which means initially time t equals 0, always. So if you're not sure, if you plug in 0 into each of those functions, you can quickly eliminate a bunch of answers. For example, if I plug in to option number C, I'm just picking this one kind of for a purpose, but if I plug in 0, what is anything to the power of 0? That's always equal to 1. So what am I left with? 0.87. That doesn't make sense because when I start with 325, when I plug in t equals 0, I should still get 325, so it can't be this one. So that kind of leaves it with A and B. And then a lot of people just went with B because they saw the 0.13. But remember, if you're going down by a percentage, that's a percent change. That's the same thing as if you go to the store, you have 20% off. If you have 20% off, how much are you actually paying? You're paying 80%. That's where the 87% comes from. A lot of people went with B when they should have picked A. Okay. Other questions? I'm going to go over 15 because 15, there's, again, easy way and a hard way to do this one. I'm going to go over both. So one thing is, I'm looking at the options. Some of them just look ridiculous. And again, I say that because I want you to get to a point where you look at them and say, oh, of course that's ridiculous. Even if you initially picked that answer, I don't want you guys to make that mistake on the test. So a lot of people want to pick something like A or B because, well, all they have to do is cancel out the X's. And if they cancel out the X's, then I have A. Too easy. That's wrong. Again, if it seems too easy, it's probably wrong theorem. Same thing in option B. Okay, cancel out the X's, so I'm left with 5 minus 2/3. So then I'm left with C or D. How do I know which one it is? How do I know? I plug in a number into X and I see if I get the equivalent value. What's the easiest number to ever plug into any function? 0. Okay. If you can't plug in 0, plug in like 1 or something like that. But if I plug in X equals 0, what do I get? -2 over +3, right? Okay, so what happens if I plug in a 0 in here? I get 5 minus 2/3. Is 5 minus 2/3 and -2/3 the same? Even without a calculator, I know they're not the same. So I know this one's out. So then what do I have? I have 5 minus 17 over 3. And maybe it's harder for me to do that fractions, but again, I could think, wait a minute, 5 minus 17 over 3, that's definitely negative. Oh, it is -2/3 because I have that remainder. Check. Okay. That's how I would do this problem. Truly. I would have first looked at this and said, can I just plug in a number and figure out which one's equivalent? That's the smart way to do this one. Okay. The way that they want you to do it, well, they actually want you to do it the fastest way possible. But another way you can do this is, if this is linear and you are doing division, you want to use synthetic division. Okay, some of you guys haven't done synthetic division in a while, so let's do a quick recap. You have a little box in the corner. You have a line, okay? You find the root of x plus 3, which means, when does x plus 3 equal 0? At -3. And then you take the coefficients of the numerator and stick them on top, which is 5 and then -2. Anytime you see division of fractions, you can always do this. First step, you drop down the 5. Next step, you multiply by -3. This is synthetic division. You saw it in algebra 2. You multiply by -3, you get -15. Step 3, you add. You get -17. You ran out of numbers, you're done. If you have more numbers, you just continue the process. Multiply and add, multiply and add, multiply and add. And then I look for these numbers and I see them beautifully standing right in front of me. Okay. Any questions on this page? Okay, flip over to the next page, 38 and 39. The only problem that really stuck out above the other ones for the grid and responses was number 19. But if you have other ones you want to go over, you know I'm happy to do it. So for number 19, they gave me a coordinate plane. Sorry. And then they gave me a point right here. And they said A, which is √3 comma 1, okay? So I'm gonna go through step by step on how you wanna think about this. For my calculus students out there, okay? Well, those look like numbers in the unit circle, but usually we're dividing by something else, aren't we? And we're dividing it by 2, right? And you can do this to shrink the circle. This is actually a legal move. And then it tells you, okay, if X is the bigger one and Y is the smaller one, what angle does that correspond to? That corresponds to the 30 degrees, or that's just pi over 6. So the value of A is equal to 6, okay? That's for the calculus students. I want you guys to go through it that way, okay? For, if that one wasn't obvious, and for my pre-calc students, you still, and I mean this, you still want to look at your triangle here, okay? The triangle here, this is your value of X, this is your value of Y, okay? The value of X is literally the X value in this value, which is √3, and the Y value is 1, okay? So now the question is, how do you have to figure out the hypotenuse? Well, if I want to find, well, you don't have to find the hypotenuse, but if I want to find the hypotenuse, I could do Pythagorean theorem, right? √3 squared plus 1 squared equals, let's see, that's 3 plus 1 equals 4. So that's going to be 2 squared. So the answer is 2. Okay. If they're going to be asking you guys trig questions and you are still a little rusty on your trig, the nice thing is, because this is no calculator and this is only going to apply to no calculator questions, you want to think back to your 30, 60, 90, and 45, 45, 90 triangles. In your SAT booklets, if you flip to page, trying to remember, if you flip to page 32, let's see, where is it? It was it this one? If you flip to page 32, you have these formulas, right? I want you to stare very closely at this one. Okay? Those numbers should be very, very familiar to you, okay? A x √3, a 1x, and a 2x, that overlaps perfectly with I don't know where I left it. Let's see. Is it this page? No. Here. That overlaps perfectly with this triangle, okay? I have a triangle where I have √3, 1, and 2. And that's 2x, 1x, and x √3. Which means this is your 30 degrees, this is your 90, this is 60 degrees. Okay? And therefore, you know that this is 30 degrees. However, they specifically want you to give you an answer in radians. Now, if you are still kind of working on making sure you know the difference between degrees and radians, then you need to find a way of converting this, okay? Again, on page 32, so page 32, it tells you at the very, very bottom, a circle is 360 degrees, and a circle is also equal to 2 pi radians. So if you ever have to convert degrees to radians, and this applies to anything that's not on the unit circle as well, 30 degrees, I'm going to put degrees over here, I'm going to put radians over here. This is just simple dimensional analysis. 360 degrees is equal to 2 pi radians. You multiply across, the degrees cancel, 60 pi over 360. Zeros cancel, you're left with pi over 6. And value of A is 6. Okay. Use the book and what they give you in the book in case you get stuck. Again, a nice little hint is in the no calculator section, they can't ask you what's tangent of 27. They can ask you a lot of stuff with 30, 60, 90 triangles and 45, 45, 90 triangles. Okay, so keep that in mind in case you ever forget. You're like, oh, I don't remember how to do this, or I'm supposed to do this without a calculator. There's a formula for that. Okay. Are there any other questions from pages 38 and 39, 16 through 20 that you guys want to go over? That one was the one that stuck out the most to me, but there could always be other ones. 17, sure. We'll go over 17. If you have another one, please let me know. So let me write this down. 2x times 3x plus 5 plus 3 times 3x plus 5 equals ax squared plus bx plus c. Got it. In the equation above, a, b, and c are constants. If the equation is true for all values of x, what is the value of b? So if the equation is true for all values of x, what is the value of b? Well, my instincts, and I could be wrong, my instincts are going to be trying to simplify this. And I know there's another way to do this, but I can't see right now. So if I distribute this, I get 6x squared plus 10x plus 9x plus 15. And if I combine like terms, I get 6x squared plus 19x plus 15 equals ax squared plus bx plus c. Okay. And then it says, what is the value of b? I would have to imagine it's 19. But I don't know if I'm missing something. Let's see. Which one was this? Number 17? Nope, the correct answer is 19. Okay. So yeah, that's all you have to do for that one. And it's just equating coefficients, because if A is something else, well, then A has to correspond with 6 and C has to correspond with 15. And it's just a matter of, this is an x squared, this is an x squared. Fine. This is an x, this is an x, fine. And this is a c and this is a c. Okay. Other questions, 16 through 20? Everyone felt pretty good about those? Okay, let's move on to the calculator section. So my questions that I saw like come up more often were not towards the end. So I'm just gonna go start off by going page by page. So are there any questions in the calculator section from 1 through 11? So I'll start with those first 3 pages. I'm gonna group them all. Are there any questions from 1 through 11 that you guys wanted to go over? Go ahead, take some time, take a look. Okay, 7, sure. All right, as you guys are still looking, I'm gonna start by going over number 7. And if you find one, let me know. Number 7. The equation above, let me write down this equation, y equals x squared minus 6x plus 8. The equation above represents a parabola in the xy plane. Which of the following equivalent forms of the equation displays the x-intercepts of the parabola as constants or coefficients? So if I'm going to try to figure this one out, a couple things I can do. I want to figure out a way of getting the x-intercepts to show up, okay? X-intercepts are always when y is equal to 0. That's a y, when y is equal to 0. Because if I think about a graph and I have a parabola, It's got to cross the x-axis. This is where it crosses, and this is where it crosses. Okay? So now the question is, okay, how do I get those numbers? I'm not really caring too much about solving for those numbers, but how do I get those numbers to show up? Well, if y is equal to 0, the question is, how would you solve for x? Because you are trying to solve for x. That's the x-intercepts. Ideally, you realize that this one is factorable. What does this factor into? X minus 4, x minus 2. Factoring, we've seen at least 3 factoring problems, so you definitely want to brush up on that if you need to. Equals 0. So then I have to have x equals 4 and x equals 2. So I'm looking for the problem that shows me those two numbers, and that's why the answer is D. Okay? Hypothetically, if you're not good at factoring, luckily, if you know how to use your graphing calculator, your TI-83 or 84, you plug this into y equals, okay? And then you try to figure out where it graphs and crosses the x-axis, and you'll figure out the same answers, 2 and 4. Okay? And as a result, if it's 2 and 4, well, therefore, you get those same numbers. Okay? You do need to know the definition of an x-intercept. An x-intercept is always when y is equal to 0. Okay? Other questions up through 11. We did pretty well on the beginning. It was towards the end where we weren't doing so hot. All right, questions from 12 through 18. 12 through 18. Sure. Oh, sorry, number 7. The answer should have been D, I believe. Let me check the answer key, make sure there was no error there. That was number 7. Yes, the correct answer was D on that one. No problem. All right, number 18. Let me read this one. A survey was taken. So these questions, by the way, just for your own personal information, you often get a science score. A lot of times when it talks about surveys and stuff like that, this question's response is also going to be factored in for like a science score or even your reading or English score sometimes. They're not always completely separate because it just matters whether you can correctly read and understand the question, depending on the difficulty. If it's too difficult, they won't factor it into English, but if it's easy enough, they will factor it in. A survey was taken of the value of homes in the county, and it was found that the mean, so mean, which is also known as average, was 165,000. And then the median was equal to 125,000, okay? Now, if I see this, if the average is 165,000 and the middle, because median means middle is 125, that means there's probably like a couple of houses that are just way too expensive. So all of the houses cost like $100,000, and then someone built $1 million house, and as a result, it threw all the numbers towards the $1 million house. Which of the following situations can explain the difference between the mean and median home values of the county? So again, I'm already thinking about these answers before I look at it. The homes have values that are close to each other. They're not too far. There are a few homes that are valued much less than the rest. No, just absent. There are a few homes valued much more than the rest. So that looks like it's a C. I'm liking that one. Many of the homes have values between 125 and 165. Maybe, but I don't have enough information to determine that, okay? So the answer in this one is C. If that is hard for you guys, so definitely know the difference between mean and median, okay? Mean is an arithmetic mean, means you add them all up and divide by that score. Median is always middle. If you ever struggle with something and you're trying to figure out what's the difference and how does things relate, what I would say is think about something that a lot of you guys make sense with, and that's grades, okay? Imagine you take 5 tests. Keep the numbers simple, because if you're gonna make up a situation, random situation for you to understand, keep the numbers simple, okay? If I get, and bear with me, if I get 60%, 60%, 60%, 60%, 100%, okay, on my tests, all right, then what is the middle? The middle is 60%. What is the mean? Well, if I add them all up and divide by 5, I'm definitely gonna get something between 60 and 70, right? Or 60 and 100. So that's what it tells me. Oh, okay, if the middle is lower than the average, then all of a sudden, well, that means that I have one outlier on the high end. Versus if it was all the opposite, if it was 60 and then 100, 100, 100, 100, if I have the middle to be 100, but the mean is going to be lower, well, that means there's one house that's much less than the rest. Okay. If you ever are trying to figure out a situation, see if you can get it to something that makes total sense to you guys. And maybe home values make sense to you, but maybe something like grades, which you guys value so much, will make a little bit more sense, okay? And hopefully, if this didn't make sense before, now it does. Other questions from 12 to 18. '17, sure. Don't be shy, guys. You guys can all ask. The atomic weight of an unknown element in atomic, see, here's another science question. In atomic mass units, AMU, is approximately 20%, here's that key word, 20% less than that of calcium. The atomic weight of calcium is 40 AMU, okay? Which of the following best approximates the atomic weight in AMU of the unknown element? So again, think about it like a discount. Calcium is 40 AMU. You're getting a 20% discount, which means you're keeping how much? You're keeping 80%. So all I want to do is figure out what 0.8 times 40 is. And the nice thing is you have a calculator if you absolutely need it. If not, figure out what 10% of 40 is. Oh, 10% of 40 is just 4. Multiply that by 8, you get 32. So the answer should be 32C. Okay, other questions from 12 to 18? Okay. Questions from 19 through 24. Okay, 23, sure. All right, as you guys are looking at those, I'll start with number 23 because I am kind of down to my last 10 minutes, 13 minutes. Let me read the entire problem because there's something attached to it. I equals P over 4 pi r squared, okay? At a large distance r from a radio antenna, the intensity of the radio signal is related to the power P. So P stands for power, R stands for distance, and I stands for intensity, okay? And then 23. For the same signal emitted by a radio antenna, observer A measures its intensity to be 16 times the intensity measured by observer B. The distance of observer A from radio antenna is what fraction of the distance from observer B? So great way of looking at this problem. I have this formula, right? All I figured out is that the intensity for observer A is 16 times than that observer B. Does the power change? No. Does the distance change? Yes. So what does that tell me? Power is constant, okay? If power is constant, one thing I can absolutely do is just pick a random number for P and plug it in. Don't pick 0 because 0 is just going to make too many things go away. It's got to have some power. Power is equal to 1, Okay, I is equal to 1 over 4 pi r squared. Okay. So now the question is, if the intensity is 16 times then for observer A than it is for observer B, fine. Observer A, they would say intensity is 1. Observer A, they would say their intensity is 16 times that. Again, I'm kind of picking random numbers, but I'm also picking easy numbers to work with. So now the question is, what is their relative distance? Okay, so I'm going to plug in I equals 1, figure out R. I'm going to plug in I equals 16 and figure out R. If I equals 1, if I try to solve for R, cross multiply, fraction on the one side, put the other one over 1, cross multiply, 4 pi R squared equals 1. Solve for R squared equals 1 over 4 pi, square root, R is equal to 1 over 4 pi inside of square roots. This is for observer B. Okay, what about observer A? Well, then I get 16 times the intensity, 1 over 4 pi r squared. So then I get, that's going to be a big number, 64 pi r squared equals 1. So then I get, let's see, r squared equals 1 over 64 pi, because I got to divide since it's multiplied. And then if I get r, it's 1 over 64 pi inside of a square root. Okay. Well, how do these two things compare to each other? What's the ratio of observer A is what fraction of that of observer B? Okay, so I'm going to take A's and divide it by B. Now, one thing that I have seen, don't try to cancel out your square roots. You can't do that, but you can simplify. This is square root of 1 over, and then this is going to be 8 square root of pi over square root of 1 over 2 square root of pi, and then everything basically cancels. And then you're left with 1/8 over 1/2. But what would happen if I multiply by the reciprocal? Then I get 2/8 or 1/4. Okay. That's the long way of doing this problem. Okay. Unfortunately, sometimes that is the most ideal way if you don't know. Okay. There is a shorter way to do this one, and it relates to talking about distance to area. If you remember that conversation I had with you guys. What is the relationship that I has with R? Well, if I is R squared, I think about this as distance and area. So again, what would happen if I took a box and I doubled its length on each side? Well, then all of a sudden I have 4 times as much. So if the intensity is 16 times as much, then R is going to be 4 times or 1/4 as much in that situation. Okay, so that's how you want to calculate that one. If you want to be quick, that's how I would do that one. Now, if you want to be sure, you got to do some sort of guessing and checking and trying to work your way through it. But ideally, you will try to see that relationship is quadratic. So therefore, in a sense, the relationship between R is the square root of that. Okay. All right. Somebody asked about number 24. Sure. X squared plus y squared plus 4x minus 2y equals -1. Sad to say, there's no other way to do this besides using some factoring, and I would highly advise everybody to brush up on their completing the square techniques. Okay, here's how we complete the square. First of all, organize all the variables together. X squared plus 4x, and then put a plus blank. Okay, y squared minus 2y plus blank equals -1. Completing the square requires you to take half of the b value and then square it to come up with this. So if I take half of 4 and square it, I take it 2 squared 4. And that means put a plus 4 on this side to balance out the equation. take half of this value, which is -1, and square it, you get a +1, put a +1 on this side. Okay? So the nice thing is, if you recall, the equation of a circle is x minus h squared plus y minus k squared equals, and the only thing that matters in this problem is the r squared. Okay? So don't even worry about playing around with the left side anymore. You don't have to, okay? Because all I care about is what is r squared. Well, this simplifies to just 4, right? So then r has to equal 2. And if the radius is all I care about, r is equal to 2. Hypothetically, let's say they did ask for the center of the circle. They might ask for that, which is h and k. Well, then if I did complete the square, then I have to take half of that b value, which is x plus 2, and write squared. Okay, it's always this value right here, the half value that goes right there. And then this one is y minus 1. Again, this value goes right here. Squared equals 2 squared. And then the center is the opposite. So the center in this case is -2, +1. Okay, if it was asked. You want to brush up on your completing squares for that one. Okay, I know I'm down to my last 5 minutes, and I do want to try to finish this. There is one other problem that really stuck out to me, is number 30. I thought that one should be a gimme for a lot of people, but over 80% of people got this one wrong, okay? All right. It says the figure above shows a regular hexagon with sides of length A and a square with, so everything is an A here. A. If the area of the hexagon, the area of this thing, area equals 384√3 square inches, then what is the area of the square? Easiest way to do this is, first of all, try to find the value of A. There's a lot of formulas that you're not going to remember when it comes to geometry. So what you want to do is make the pictures smaller. What can you do? Change this all into triangles. Why? Because it's a hexagon. A circle adds up to 360 degrees. So what is 1/6 of that? That's 60 degrees right here. And if that's 60 degrees, and these are congruent because guess what? They're both legs and they have to all be equal. Then these are all 60 degrees. And that means you have an equilateral triangle. I hope all of you guys walk into the next SAT with this formula memorized. The area of equilateral triangle is always s²√3/4. Okay? Equilateral triangles show up all the time. Now, if the area of this whole thing is 384√3, then if I divide it by 6, so the area divided by 6 will give me the area of one of the equilateral triangles. So what's 384 divided by 6? That's 64√3. 64√3 should equal this thing, s²√3/4. Cancel out the √3s, multiply by 4. So what is that? 256. S is equal to, what is that? 256 square root of that should be 16, I believe. 256, yeah. So if A is equal to 16, which is this side, then what's 16 times 16? Well, that's just back to 256. Okay. The one thing I want you to walk away from going over this problem is this formula. I've seen this formula on every SAT, and it makes the problem go by faster. Okay. All right, with 2 minutes to go, I'm going to make one announcement. If there is a e-learning day tomorrow, okay, Make sure you guys check Google Classroom for whatever your SAT teacher or your regular teacher puts out there, you know, just in case there's one of those. And then if you have any questions, let me know. Otherwise, you guys can have a great day.